So in this video, we're going to start taking a look at ellipses. So we looked at circles, and we hopefully understand the general idea of a circle where it's perfectly round. An ellipse is an oval shape, right? So an ellipse is the set of all points in a plane such that the sum of the distances from the fixed point is constant. The two fixed points are the foci, singular for focus, or the singular is focus. Foci is the plural. So you can see my silly little lines here going, I'm pointing at focus 1 and focus 2 here. So you can see that they're, the sum of the distances from the 2 points is fixed. So it's an interesting way of thinking about it, but we have our distances. Oh, and I'm clicking buttons here. So the line through the foci intersects the ellipse at 2 points called the vertices. So you can see if I connect, they continue going through the vertices here. And the singular is vertex. The segment joining the vertices is the minor axis. Its midpoint is the center of the ellipse. That's funny. That should say center of the ellipse. Okay, so its intersection right here is the center. So the minor axis, the segment joining the vertices, okay, so the line through the foci intersects the ellipse at 2 points called the vertices. Singular would be vertex. The segment joining the vertices is called the major axis because it's going across the widest part of the ellipse, and its midpoint is the center of the ellipse. Okay, the minor axis, which is the one going across the skinniest part of the ellipse, passes through the center, and it's perpendicular to the major axis. It intersects the ellipse at 2 points called the co-vertices. Singular would be co-vertex. Okay, so if we take a look at this one, so you can see that this one's labeled horizontal, and then you can see the vertical one down here. We'll look at that at the next page. So if it's a horizontal major axis, like the one we can see here, so it's going from left to right, that's the widest part of the graph, then we have x minus h squared over a squared plus y minus k squared over b squared equals 1. This will always equal 1. That's not going to change in the vertical, but what is going to change is the a and the b in this case. So because you can see a is the longer leg, it's the half of the major axis, and b is half of the minor axis. So if I flip this and I'm looking at a vertical, well, then that means that a is going to be the longer, it's going to be over my y, and b would be over my x, because it's going to switch the two legs, because it's the longer leg and the shorter leg, if you can kind of help remember that. So if the longer leg is on the kind of going left and right, then that means it's going to be a horizontal major axis, and it's going to be under the x squared, or x minus h squared. The center is hk. We have our vertices. So if it's horizontal, we have h plus or minus a, because we have two vertices, right? I have to add a and I have to subtract a, and then the y coordinate is going to be k. The co-vertices, I just do kind of the opposite here. I have my x coordinate will be h, because it's right above or below the center, and I'll take k and I'll add b and I'll subtract b. So that's how I find the vertices and the co-vertices. The foci, so because the foci are on the major axis, I'm going to add or subtract c from h, and k will stay the y coordinate. And c I find with kind of Pythagorean theorem. It's usually a squared plus b squared equals c squared, but for this case we do a squared minus b squared equals c squared. So if we need to find the foci, that's how we'll do it with the c. Let's take a look at the vertical major axis option. So you can see now it's a tall. So now, like I was saying, now a is tall, it's going up and down, and b is going side to side, and it's shorter. So it's switched. X minus h squared and y minus k squared, they're still in the same positions, but now b squared is under the x, and a squared is under the y. Because it's tall, and we're switching that. It's still, b is still, is considered the x because it's going right and left, and a is y because it's going up and down. So we kind of switch the positions there. So just look at which direction are they going. And then down here, if you notice, it kind of flips around a little bit. So now h stays, and I add a to k. So if we go back, we were adding a to h for the horizontal, but now I'm switching because now if I'm looking at the vertice, well, if I'm starting here and I want to go to the vertice, h is going to be the same because that's my x-coordinate. I'm not going to move right or left. I'm going to go straight up or straight down by that term of a. And then for my covertice, well, I'm not going to go up or down, so k is going to be the same, but I'm going to go h plus b or h minus b. And then the same thing with the foci. The foci are on the major axis, so it's going to be k plus c or k minus c, and we still find it the same way with that c squared equals a squared minus b squared. So there are a couple things to note here. If the x term has the larger denominator, a squared, the ellipse will be horizontal, so we already kind of looked at that when I was talking through it. So if a squared is underneath the x, then it's horizontal. If it's under the y, then it's going to be a vertical ellipse like we see here. So we want to pay attention to which one is larger. Is this number larger or is this number larger? Because that tells us is it horizontal or vertical. The length of the major axis is 2a, and the length of the minor axis is 2b. So hopefully that makes sense. If this length is a, well, then the whole length across is 2a's, right? Or 2a. And then b, if I want to go all the way across, it's 2b. So I have x squared over 16 plus y squared over 36 equals 1. And my first question here that I'm asking you is, what is the center? So I'm saying it's 0, 0. Well, how do I know that? Well, remember it's x minus h squared and y minus k squared. If I don't see anything being subtracted, it means it's x minus 0 squared, which would just, the minus 0 would disappear and it'd just be x squared. And same thing with the y here. So it's because there's nothing being added or subtracted to the x squared or y squared, I know that it's zeros. Okay? So I know my center is going to be 0, 0. Is this horizontal or vertical? So I'm saying vertical, and how do I know that? Well, here's my 36, that's bigger than 16, and 36 is above the y. So y squared has the larger denominator. This is my a squared. So that means it's taller than it is wide. Okay, so now I'm going to go through and I'm going to answer my a and b, and that's important to identify the vertical. So now that I know 36 is my a, so I'm going to take the square root of 36, and I'm going to take the square root of 16, because this is a squared and b squared. So now a is 6, and b is 4. And that'll definitely help me graphing when I go to graph either a or b when I'm graphing the sides. So I can go through and I can identify my covertices now, because I have 0, 0, and then the y coordinate is 0 plus 6, because I'm adding my 6 to that. And then I also have to do minus 6, because I have to go up and down. So this is going to be 6 and negative 6. And then for my covertice, I'm going to go to the right 4, and I'm going to go to the left 4, right, from 0. So when I'm graphing this, you can see I only graph 3 points. So I graph the center, and then I graph A, and I graph B. And the reason I do this is because Alex is actually going to, that's all it requires to graph. And I'm going to show you a little video here of me doing it on Alex so that you can see it. So I'll go ahead and click play. So you can see me, I clicked on the ellipse, and then I clicked center. I placed my vertice, and I placed my other vertice, and it automatically snapped it into place. I didn't have to do anything else. So that was really quick. You can see it again. So I placed my center, I placed my A, I placed my B, and then I'm done. That is all Alex expects us to do. So it's a very, very easy process. So you don't even really need to find all of your vertices. You can find one of each, and that's perfectly fine. But you can actually use your A and your B too, because I can go from my center, I can go up 6, I can go left 4, and that is all I need to graph an ellipse. All right, so that was Graphing Ellipse. I hope that helped, and I will see you in the next video.